steps what we have taken to find the equivalent resistance and the current in the circuit. So it goes like this. This is the original circuit of the network. We have taken 5 and 2, the equivalent resistance between A and B if we are bothered about, that is what is the resistance between A and B if we talk about. So 5 plus 2, 7, A is here, B is here, C is here. So 5 plus 2, that is 7, it makes 7. 4 ohm is over here, 7 plus 5, so they have been replaced by a single resistance of 12 ohm. We go to the next step. So this is 7 ohm between A and B. Between A and B, 7 ohm is represented over here. Between B and C, we have two resistances, 4 ohm and 12 ohm, which are parallel. So we have removed this and we have replaced by one single resistor of 3 ohm between B and C. Now when we look between A and C, that is A and C, these two resistors, they are in series, that is 7 plus 3, that is equal to 10. So this is a 10 ohm is the resistance, equivalent resistance of the circuit. So this is 10 ohm, this is 20 volt battery, which gives a potential difference of 20 volt. Over here the current we can find using the Ohm's law, V is equal to IR, potential difference is 20 volt, I into 10, that is I comes out to be 2 ampere. If we are interested, what is the current which is passing through this 4 ohm resistor? Let's say we are interested in finding what is the current which is passing through the 4 ohm resistor. We can solve this once we have found that what is the current which is coming out of the battery, that is 2 ampere current is passing through this. Then certainly we can find the potential difference across all the resistors using Ohm's law. Let's say if we go from now in the reverse manner, if we go, that is current is 2 ampere. If the current is 2 ampere, it is from here it is going 2 ampere. So 7 into 2. So this is 7 into 14 volt is the potential difference across this, and 3 into 2, that is V is equal to IR. V is equal to I is 2 ampere, resistance is 3 ohm. So this is 6 volt is the potential difference across this 3 ohm resistor. So 14 plus 6, that makes once again 20 volt. Between A and B, the potential difference is 14 volt. Between A and B, it is the potential difference is 14 volt. Now we go once again one step backward, and over there we find that is between A and B the potential difference 14 volt. So potential difference between 14 volt. Between B and C, if we see over here, that is between B and C, it is potential difference is between B and C is 6 volt. What does it mean? It means that is if we take these two resistors, one is this is 4 ohm, and over here we have a resistance of 12 ohm. Between B and C, it is equivalent to, that is we have a battery or potential difference of 6 volt, because the conventional current is flowing in this direction, and we know the conventional current or positive current flows from a higher electric potential to lower electric potential. The current is flowing in this direction, so it means this is at a higher potential, this is at lower potential. So that's why when we say 6 volt battery, we have not made this as positive or this is negative. This is at a higher potential because this is at a higher potential, this is at lower potential. So the terminal polarity will be something like this. So this is going to be positive, this is going to be negative. So when we know that is the potential difference between this and this is 6 volt, so across this also 6 volt, across this also 6 volt. If we take for 4 ohm, we use V is equal to IR. Let's say we call this as from here, let's say current is I1, and in this arm suppose the current which flows is I2. Certainly that is I current comes over here and this gets split into 2. So I1 is, when we use V is equal to IR, V is 6 volt across this resistor. The potential difference is 6 volt. I is, we call it as I1 into R. So I1 is 6 by 4 is equal to 3 by 2 ampere. If we take this, if we are interested in finding I2, we say once again V is equal to IR, V is 6, I is I2 into R is 12. So I2 comes out to be 1 by 2 ampere. If we add I1 plus I2, that should be this current only, that is which is passing through this. So I1 plus I2, that is half plus 3 by 2. That is 3 by 2 plus half is equal to 4 by 2 is equal to 2 ampere. Obviously the current which flows the circuit, it gets split over here. Some current flows through the 4 ohm resistor and some flows through the 12 ohm resistor. Whatsoever the current is, what is the value of current? Current we have seen that is over here, it is coming as 2 ampere. So 2 ampere when it comes over here, some splits, some current goes through the 4 ohm resistor and some current goes from the 12 ohm resistor. Through the 4 ohm resistor, it is 3 by 2 ampere. Through the 12 ohm resistor, it is 1 by 2 ampere. 3 by 2 plus 1 by 2, it makes once again 2 ampere current only. 2 ampere current, it splits over here and once again it rejoins, and this is once again, this is 2 ampere current flows back into the battery. Battery is not a source of charges. It is impossible that the battery gives some charge and it takes back a lesser or a more charge. Whatsoever charges, they are pushed into a circuit. At the same instant, these charges, they are once again retained back by the battery. So if we put the emitter, now if we have put the emitter second, we have put a one more meter to measure what is the current which is flowing through this arm, that is 4 ohm resistor. We'll get the reading of A2, that is emitter 2, as 3 by 2 ampere, and if we put a emitter over here, so A3 will show a reading of 1 by 2 ampere.